Welcome to the world where machine efficiency rules. Today, we delve into the importance of understanding why machines fail. It's a topic that often slips under the radar, but it's crucial to the smooth running of any operation, big or small. Imagine you're a doctor. To cure a disease, you first need to diagnose it, right? The same goes for machines. To prevent failures, you first need to understand why they occur. Understanding machine failure is like having a secret roadmap that guides you to the root of the problem. It's the first step towards effective troubleshooting, and it helps you prevent similar issues from cropping up in the future. But why is this so important, you may wonder? Well, let's paint a picture. You're in charge of a production line. One day, a machine fails, production halts, time and money are lost, and the ripple effects can be felt throughout the entire operation. The cost of machine failures isn't just about the immediate repair or replacement expense. It's about the downtime, the lost production, and the potential knock-on effects on other aspects of the business. Now let's flip the scenario. You understand why machines fail. You have a robust maintenance strategy in place. When a machine shows signs of a problem, you can identify and address the issue promptly, minimizing downtime and disruption. You're not just reacting to problems, you're preventing them. That's the power of understanding machine failures. So, what causes machines to fail? Well, the reasons are many and varied. It could be down to incorrect design, material defects, incorrect operation, or inefficient maintenance. Each of these factors can contribute to the premature demise of a machine. By understanding these causes, you can take steps to mitigate the risks and enhance your maintenance strategies. In a nutshell, understanding why machines fail allows you to be proactive rather than reactive. It enables you to extend the life of your machines, optimize your operations, and ultimately save your company time and money. Indeed, understanding machine failure is the first step to efficient machine maintenance and risk mitigation. Join us as we delve deeper into the causes of machine failure and explore strategies to prevent them. Stay tuned. To unravel the mystery of machine failure, we must first explore its causes. Let's delve into the four primary culprits. First up, incorrect design. Design flaws are an insidious cause of machine failure. They can lead to operational inefficiencies or even total failure under normal operating conditions. Imagine a car designed with its exhaust pipe too close to the fuel tank. It's a disaster waiting to happen, and it's no different when it comes to machines. Next, material defects. The quality and suitability of materials used in machine components are paramount. Inferior or unsuitable materials can be the Achilles heel of machines. It's like building a house on sand. No matter how beautiful the house, it's bound to collapse sooner or later. The third cause, incorrect operation, is sometimes overlooked. Operating machines beyond their design parameters, such as temperature, load, or speed, can lead to premature failure. It's like running a marathon without any training. You might make it to the finish line, but you'll likely collapse before the end. Last but not least, inefficient maintenance. This is a major contributor to the degradation of machine components. Lack of proper maintenance can accelerate wear and tear, leading to unexpected breakdowns. It's akin to neglecting to service your car, and then wondering why it broke down in the middle of a road trip. In essence, machines are like a symphony orchestra. Each component, each process, has its part to play. If the design is flawed, the orchestra is out of tune. If the materials are subpar, the instruments fail. If the operation is incorrect, the music becomes a cacophony. And without efficient maintenance, the orchestra's performance degrades over time. These four factors largely contribute to machine failure, but with proper understanding, we can avoid these pitfalls. Remember, prevention is always better than cure. And understanding the causes of machine failure is the first step in prevention. Let's connect the dots between poor maintenance and company profits. When we fail to maintain machines properly, we incur both direct and indirect costs. Direct costs include the immediate consequences of downtime, lost production, and the use of spare parts. Indirect costs, on the other hand, are not as apparent but just as significant. They encompass premature filter replacement, disposal costs, higher energy consumption, and even inflated insurance costs. Now, consider this. Every pound saved in maintenance costs directly benefits your bottom line. By reducing the frequency of machine breakdowns through efficient maintenance, you save on repair costs and downtime. Indirectly, you also save on energy consumption and disposal costs. And let's not forget, a well-maintained machine is a safer machine, which could lead to lower insurance premiums. Remember, each penny saved in maintenance directly enhances the bottom line. Now, let's look at the role of a lubrication engineer's best friend, effective lubrication. Lubrication, in its essence, is the lifeblood of any machine. It's the magic potion that keeps the cogs turning, the wheels spinning, and the engines roaring. But it's not just about slapping on some oil and hoping for the best. Effective lubrication is an art. It's a science. It's about understanding the machine, its needs, and how best to meet those needs. Firstly, one of the primary roles of lubrication is to reduce wear. Wear is a machine's worst enemy. It's the silent killer that slowly but surely grinds away at the machine's heart. By providing a thin film between moving parts, lubrication prevents metal-to-metal contact, drastically reducing wear and extending the machine's life. Secondly, there's friction. Friction generates heat, and heat is another machine killer. By reducing friction, lubrication keeps the machine cool, ensuring smooth and efficient operation. Then there's the issue of noise. Machines can be loud, and excessive noise can be a sign of trouble. Effective lubrication reduces noise, making for a quieter, more pleasant working environment. And let's not forget about energy consumption. Less friction means less energy is needed to power the machine, leading to lower energy costs. Effective lubrication also reduces lubricant consumption. It might seem counterintuitive, but the better the lubrication, the less of it you need. This not only saves on costs, but it's also better for the environment. Finally, we come to product contamination. In industries where cleanliness is paramount, such as food processing or pharmaceuticals, effective lubrication can prevent contamination, ensuring the integrity of the end product. So you see, lubrication isn't just about keeping the machine running, it's about optimizing performance, extending life, reducing costs, and safeguarding the product. It's about understanding the needs of the machine and meeting those needs in the most effective, efficient way possible. Indeed, effective lubrication is a key player in failure avoidance. Let's dive into the world of maintenance strategies. Two key strategies come to the forefront when we talk about machine maintenance: predictive maintenance and proactive maintenance. Both these strategies have their unique benefits and applications, and understanding them can greatly enhance the lifespan and efficiency of your machines. Predictive maintenance, as the name suggests, is all about predicting potential machine failures before they occur. It uses condition monitoring tools and techniques to track the performance and condition of equipment during normal operation. This allows us to identify any significant changes that could indicate a developing fault. It's like having a crystal ball, predicting the health of your machine in real time. Proactive maintenance, on the other hand, focuses on avoiding failures in the first place. It's a step ahead of predictive maintenance, where we're not just predicting but actively preventing potential breakdowns. Proactive maintenance involves activities like routine lubrication, component replacements, and regular inspections. Now you might be wondering, where does lubricant analysis fit into these strategies? Well, it's a crucial part of both. Lubricant analysis can help identify potential issues in the early stages, making it a great tool for predictive maintenance. It also plays a significant role in proactive maintenance by ensuring optimal lubrication of machine components, thereby reducing the chance of premature wear and tear. But no maintenance strategy is complete without efficient lubrication routes and scheduling. Establishing a precise lubrication route ensures that all parts of the machine receive the right amount of lubrication at the right time. This, coupled with a well-planned lubrication schedule, can significantly improve machine performance and longevity. So remember, a well-oiled machine isn't just about literal lubrication. It also involves strategic planning, predictive and proactive measures, and efficient scheduling. It's about understanding the machine's needs, predicting potential failures, and taking steps to prevent them. An efficient maintenance strategy is the backbone of a well-functioning machine. As we wrap up, let's reinforce the importance of understanding machine failure causes. Identifying the root causes, be it incorrect design, material defects, improper operation, or inefficient maintenance, is crucial to mitigating risks and enhancing maintenance strategies. Equally important is the role of strategic maintenance practices. Predictive and proactive maintenance strategies, as well as condition-based maintenance, play an integral part in preventing machine failures. By understanding and implementing these strategies, we can significantly extend the life of machines and optimize operational efficiency. Let's not forget the role of effective lubrication. It's a simple yet powerful tool in our arsenal, helping to reduce wear, friction, heat, energy consumption, noise, lubricant consumption, and product contamination. In conclusion, understanding machine failures and implementing strategic maintenance practices are not just about fixing problems, they're about preventing them. Remember, understanding machine failures and implementing strategic maintenance practices can significantly enhance machine life and operational efficiency. Don't forget to like and subscribe for more insights into the world of machines.